All right, so we did 4-6, and now we're going to talk about 4-7, the last of the equations of a line. So again, we have those, we're going to keep hitting it. We have three forms of a line. Standard form, which we said was ax plus by equals c. Not really good for a whole lot of things in terms of, graphing or whatnot, but we can standardize it. That's how we standardize it so that everybody would have the same equation. We are going to use slope-intercept, which we just learned about, and hopefully you guys did well on that. That form makes it really easy to graph with and to pick out the rate of change or the slope. And then the last one's going to be a point slope, and it's really just used to transition to one of the other two forms. And it's used when you're given a point or 2 points and a slope. So slope-intercept you'd use when you have a slope and an intercept. Point-slope, that hence the name, when you have a point and a slope. Okay. Now the point-slope is a form is y minus the y-coordinate, which is y sub 1, equals the slope times x minus the x-coordinate, x sub 1. So again, this y right here, oops, I don't know why I had it on erase. Sorry about that. Let's change colors. This y right here and this x right here, we never fill in for. That's the same as this y and this x here. But this y and this x, that's our point. That's going to be a point that we're given on a line, x1, y1. So those will be actual values, okay? Notice that on our formula, we have some negatives. So that means that when we put the point in, it'll actually go in opposite. And when we pull it out, it will go out opposite. That's the hard part of this form. So pay attention to that. So if we want to write the following lines in point slope form, we have a slope of 1/6 and it passes through the point 5, 1. So we're just going to plug in y. We're going to be very careful because there's a lot of negatives in this. Y minus the y-coordinate equals the slope times x minus the x-coordinate, okay? And so our y-coordinate is 1, and our x-coordinate is 5, and our slope is 1/6. And so if we neaten this up, we say y minus 1 equals 1/6 x minus 5. Okay, and that's it. That's the point slope. Now take a look at it. It looks like our slope is -5, -1, but it's +5, +1, and that's because of these negatives in the formula. So if I wanted to pull my point out, I would say, okay, they got to come out opposite. My x is going to be 5, and my y is going to be 1, and they'd come out 5, 1, which is what we started with. All right. So if we wanted to do the second one, we have a slope of -4 and it passes through 0, 3. We would say y minus the y-coordinate equals the slope times x minus the x-coordinate. So our y-coordinate is 3, our x-coordinate is 0, and our slope is, I just blew that. Hopefully you're saying, Mr. D, what are you doing? All right, our x-coordinate is 3, and our slope, gosh, I'm really blowing it. How about we do it the right way? Let's see, x minus our x-coordinate is 0, and our slope is -4. So we're going to get y minus 3 equals -4 x minus 0. Well, x minus 0 is just x, so it would be y minus 3 equals -4x. And we can simplify it. If you were to leave it like that, it would be fine, but we want to simplify it as much as we can, okay? So if we graph, this is really easy to graph, except that one very important thing. Your point comes out opposite. Okay? So if we take a look at this, we can easily see that this is our x-coordinate and this is our y. But when we pull them out, we're going to pull it out this way. X is going to be -2 and Y is going to be +4. And that's because if we plug them into this formula right here, we have these negatives that change it. Okay, so if we were to put these back in, we would get -2, which is +2. So that's the key. All right, and so that's easy to plot. We'd go over -2 and up 1, 2, 3, 4. And there would be -2, 4, okay? And then our slope is 3/4. So we would go up 1, 2, 3, and over 1, 2, 3, 4. And graph our line. And that makes it really easy to graph. Again, we want to take a look at it before, whenever we graph, did we get a positive sloping line? Because our slope is positive, and we did, okay? And we've got to get this coordinate, so that's, we start at the origin right here, so we go over 1, 2, and up 1, 2, 3, 4, 5, 6, 7. So this would be 2, 7. All right. Okay, and lastly, we want to use it. This is where we usually use it to go ahead and transition into standard form. So we're first going to write the equation of a line with slope 3 and a point -1, 4 is on the line. We're going to write it in slope-intercept. Why? Because they gave us a slope and they gave us an intercept. They had given us a slope, point and a slope. If they'd given us a slope and an intercept, okay. So we're going to do we're going to do all of them here. Okay. So we're going to go ahead and say, well, we can say, since they gave us a slope and a point, let's put it in point slope. So y minus the y coordinate equals the slope times x minus the x coordinate. So our y coordinate is 4. Our x coordinate is -1. That's why we got to be careful with these double negatives. And our slope is 3. Okay? So we'll say y minus 4 equals 3x plus 1. So there's point slope form. If we want to put it in slope intercept, remember that's y equals mx plus b. So we would just go ahead and say y minus 4. Let's go ahead and distribute this. Equals 3x plus 3. And we would move this 4 over. And we would get y equals 3x plus 7. And there it is in y equals mx plus b. So we can transition to it to y equals mx plus b. If we wanted to put it in standard form, we would say y equals 3x plus 7. We'd go ahead and subtract y from both sides. We get 0 equals 3x minus y plus 7. Subtract 7. We get minus 7 equals 3x minus y. Or we can just turn this around to be 3x minus y equals -7. And there's standard form. Our ax minus by equals c. So we can do that on all of those, okay? Point slope, we can go from, if they give us again, what was our key? They gave us a slope and they gave us a point. So we put it in point slope. Then we rearranged it to slope intercept, and then we can rearrange it to standard form. All right? So that's the last one, and we've almost finished the chapter. So you guys are going to do 4, 7, 17 through 29, odd, and 40 through 42 all. Again, hope you had a good day, and we'll see you in class.